So let's look at another example. This one can be found on page 245 of your textbook. So a parking lot is charging a flat rate of $3 and $1.75 per each additional hour of parking. So I look at this question right away and I notice that, to me, a flat rate means a constant. So $3 just to get into the lot and $1.75 for each hour that you're actually going to park in the lot. Okay? So even before I look at the question, I'm thinking I can easily make a linear equation out of this from our past chapter 8 and what we've learned so far in chapter 6, right? So I know that the cost for me to park in this lot is going to equal the variable of $1.75 multiplied by hour, because X, plus an additional, or there's always going to be a $3 charge. So I know how to do this even before I'm reading what A, B, C, D, and E is in this question. Okay, so actually this is the last part of this question, but I think I'd do it first. But it depends on you. Okay, so I take the information and I look at A, and it says create a table of values for the first 8 hours of parking. So if I'm going to create a table, the easiest way to do it is a T-chart. And I got to think of which is independent and which is dependent. I look for time. Time is almost always independent. Almost always, not always. So my X will be equal to my time in hours. And my Y will be equal to the cost of parking in the parking lot, right? So if I go over here and I make my table, just make a standard T-chart table, okay, put an X, put a Y, I write down the numbers for parking, I can determine the cost, so I take $1.75 plus 3, gives me the first value, which is $4.75. The next one, I take 2 and I multiply it by $1.75, then I add 3 and I get $6.50. So really, I am using my equation, even though the question doesn't ask for it till the end, right? I think it's just easier. You might just find it easier, just calculate it on your own. So I'm going to fill in this chart and then come back to the video. So as you can see, I filled in all the values. I did the math. You can check to see what the change or what the difference is. If I look from here to here, I do see a change of $1.75 as I go, right? Which is equal to my slope in this question. Okay, so if you go back to the patterns thing we did at the beginning, you notice that your slope is your change, which is also equal to the change in the Y values. Okay, so another thing you could do here, maybe I shouldn't use X and Y. Maybe X should be my hours. The yellow doesn't work. Maybe I should label this hours. And then I can label the Y values my cost. Okay. So the next part of the question asked us to graph it. So here's my graph. My X is my time in hours, and my Y value, or my vertical, is the cost in dollars. And you want to put your units in brackets. That's just the proper way to write a graph. We could give this graph a title, maybe at the end. We can give it, so we just go and we graph our ordered pairs. We make some nice lines here that are equal distance apart. I don't know how to get graph paper on this. If I did, I would know. So I'm just going to complete the graph off the video, just so I'm not talking while I'm graphing. So I got my X. It's easy. It's just 1 through 8 for each hour and change. But my Y, well, I got a lot of change. Like, it starts at 0, because I know if I didn't enter the parking lot, I wouldn't spend any time there. Therefore, I wouldn't have to pay not to be in a parking lot. I'm going to go up by 2s. It makes more sense to go up by 2s in this example. You could use a lightning bolt if you want, but you don't need to. But I'm going to go up. I'm going to start at 2 here, and then I'm just going to keep going up until I get up to my 18, I think. Okay, so I got my X values labeled. I got my Y values on my graph labeled. I guess I could put my title now. So I'm thinking of just calling this parking lot charges. Maybe cost would work as well. Cannot write an L on here. Lot cost. And now I'm just going to graph my data. So I'm going to graph everything. I want to make a nice scatter plot, and then from the scatter plot I could find where my line of best fit is. So my first data from the previous slide was when I was in the parking lot for an hour, I'd pay a fee of $4.75. I'm going to just roughly estimate that. If I didn't enter the parking lot, though, it's a flat rate of 3 to park for less than an hour, right? So 3 would be my point there. At 2 hours, if I stayed in the parking lot, I would spend about $6.50, so maybe that's right about there. If I was there for 3 hours, it would be $8.25. So I'm just going to graph this offline, and then I'll come back on right away. So I graph my points. Now, if I was on graph paper, this would work. Then I'm just going to go and connect them. And you see I do actually get not bad of a straight line, right? So my points roughly figure out into a straight line of increasing slope. Okay, so I got my title for my graph. I got my axes labeled, which is good. I have an equal number of distance between each of my numbers on my graph. And I have a line. Okay. So my line, my equation again, is C is equal to 1.75x plus 3. Okay, so if I didn't have the equation, I could use the graph, right? So the next two questions in this question in the book said, C was, use the graph to approximate how much it would cost to park for 4 hours. Okay, so if I don't have the equation and I'm given a graph, how would I figure out a value from the graph? So if I'm given the x value, so I'm given the 4, okay, what would it cost me to park at the thing, at the state, or whatever, at the parking lot for 4 hours? Well, if my graph was right, this dot would be over here, right? So I already calculated the 4, right? When I did the t-chart, at 4, it would cost me approximately $10. Okay, so for C, it would cost me $10 to park in this lot for 4 hours, right? And D says, using the graph, approximate how long you could park if you had $15.25. Well, that's the opposite thing. So I go on my Y, or my vertical line, I find out approximately where 15.75 is, so it's close to 16. So I'll kind of draw a line out from there, and I'll draw until I touch the graph. And lo and behold, I'll bring the number down again, and it's 7 hours. Okay. Now, if I interpolate, or which I did here and here is interpolation, I can do that if I have exact values. Now, in between, it depends what their rule is at the parking lot, right? If I park, say, for 4 hours and 10 minutes, they might charge me the whole $5. So there might not be actually any data in between here. Okay, so this line is just that approximation again. The best thing to do is to always use the formula. And then E was, what's the equation for this situation? So that's probably all you need to be successful in Chapter 6, is to be able to graph, be able to figure out the equation, either using a t-chart or from the graph itself, thinking of the y is equal to mx plus b formula, and just answer the questions in the textbook. So if you're given an x, what's the order pair or the value that will satisfy y, and vice versa. So you can do it with a graph, with a t-chart, or with an actual equation. So you get some choice there. So once again, complete your textbook questions, and if you have any questions for me, just ask. I hope these videos are helpful. See you.